All right. So you have the integral from 1 to 2 of x squared minus 3 dx. So that becomes 1/3 minus 3x. Now, no plus c, straight bar, 2 to 1. So fundamental theorem of calculus says upper minus lower. So it becomes 2 cubed over 3 minus 3 times 2. So that's f of b minus, so it's f of b minus f of a. So a is the 1 being plugged in, so that's 1/3 minus 3 times 1. So it's f of b minus f of a. So again, a, f of a, b, f of b. Good?
Great.
Clean up your algebra. 2 cubed is 8. So you get 8/3 minus 6 minus 1/3 plus 3.
Yeah, plus 3. Oh. You definitely put the
Oh, I did write them backwards. No, I didn't write it in room here. I just wrote them. Oh, phew. Flipped up there for whatever reason. Okay? So, -6 and +3 is -3. 8/3 minus 1/3 leaves you 7/3 minus 3. So, you're going to have to...
Wait.
7/3 minus 3. So, you will have to create a common denominator.
I was going to say, am I right or am I right or am I right? Shut up, Mama. You're really just... Everybody's coming at me. Yeah, I got a whole sleeve.
Out of strength.
What?
Okay? In example B, I would bring out the 3. So I would rewrite example B to be 3, the integral from 1 to 4, and I'd rewrite my square root as a 1/2. So you have 3, the integral from 1/2, or 1/4 of x to the 1/2 dx. Now, apply your power rule. Just because it's a constant, it's a good habit. You push it back in. Okay, 1/2 plus 1 is 3/2. 3/2 goes in your denominator. From 4 to 1. So you would flip it exactly, and it'd be like 3 times 2 divided by 3. So this becomes 2 x to the 3/2 from 4 to 1. So again, when you have bounds, FTC says no more C. Plug them in. 2, 4 to the 3/2 minus 2, 1 to the 3/2. So when you look at this, again, this would not be a calculator. Like, you would not use a calculator to do 4 to the 3/2. I would take the bottom part first, which is the square root of 4. So square root of 4 is 2. 2 cubed is 8. 8 times 2 is
16. 16 minus 2. That's a good number. Yeah, it's 2 times 7. No, it's not baseball.
Okay. What is the derivative? What function gives the derivative secant squared? So, secant squared x dx becomes tan x from 5/4 to 0. Tangent of 5/4 minus tangent of 0. So tangent of 5/4 is, tangent of 0 is,
What would happen if we were undefined at one of those points?
Whole integrals in the phone.
it's not continuous.
Yeah, because tangent goes.
Okay, example 2. Evaluate the following definite integral using the definition of an absolute value. So what do we know about an absolute value?
Everything's
Okay, but an absolute value is actually what type of function?
too long.
So 2 lines, which would make it a
Piecewise.
piecewise.
Yeah,
I'm thinking the same thing.
Use the other end, it's a V.
Okay, a 2x minus 1. Where would this absolute value split?
-1.
Okay, so
0.
yes, because it is shifted down 1 and stretched by 2, or shifted left 1 rather. It's on the inside. So you need to know where your vertex would be to know if the part you are looking at is inclusive or non-inclusive. So, no, it is differentiable, but you have to split your integral. Yes.
What does the vertex tell you? So I can write it down.
So it would tell you where the absolute value changes on the piecewise. So you would need to split your integral at that change. So again, this graph is shifted down 1 and has a slope of 2. So it will be at... Hmm? We're only evaluating the 2x minus 1 because we're going to look at the positive piece.
Good sure again. Sorry about that.
So we're evaluating from 0 to 2, the absolute value of 2x minus 1 dx. The f of x we're looking at on the piecewise is the 2x minus 1. Using your power rule to bring this back, you get 2x squared over 2 minus x from 2 to 0. What's really nice is when you have a lower bound of 0 and x's, what happens to them? So this is really like 2 squared minus 2. Okay, FTC says find the area bounded by the graph of y equals 2x squared minus 3x plus 2. The x-axis in the vertical lines, x equals 0 and 2. So, convert that into an integral. Convert it into an integral.
So we're just integrating that from 2 to 2.
Yep.
Simple enough. So we just ignore where the C would be.
So there are no plus c's when you have a definite integral.
Okay.
So indefinites mean plus c's, definites are not. What do you know about the graph of this? This is a quadratic, right? So, and it says it's bounded by the x-axis 0 and 2. Would any of this part of this parabola be below the x-axis? No, because it's shifted kind of up to over here and translated to reinforce for your vertex, but everything will be above. So this parabola has no real roots.
I'm getting -0.
Mm-hmm. Yeah.
Wait, cold hard facts.
I did that.
What is wrong?
Absolutely nothing.
Oh no, you said wait.
I didn't say wait.
I know, eat it.
Wait. More. I don't know why, but I think we just always a cracker.
How did we get?
Are they so good?
I don't know why. It just looks so satisfying.
How did we get?
Oh, where are all these
Six
examples,
plus
dog?
4, and then we get.
-6 plus 4 is -2.
But
I have only
So take -2 times 3 over 3. Which will make it -6. So 16 minus 6 is 10.
okay, I did not think of it as a -6. I just thought it was 6 plus 4, which is 10, and 16 minus 10.
And -6 plus 4 is not 10.
Yeah, I know. I didn't think of it as a -6.
Well,